Hello students. Today we're going to take a look at two topics. First we're going to look at the natural exponential function, and then we're going to look at simple interest. So far we've seen a few different exponential functions, and there are two that are fairly common. The first of these is f of x equals 2 to the x power. This is common because it shows up often when we're looking at bacteria growth, and also having 2 as a base works well because it's a fairly small number, so the calculations are a little bit easier to manage. So this is one that's fairly popular. Also, f of x equals 10 to the x is fairly popular and useful. One of the reasons is that we use a base 10 number system, so there are many situations where powers of 10 pop up. But there's a third one that is used in a lot of different situations, and this is f of x equals e to the x power, where e is not actually a variable. It's a letter that we use to represent an irrational number. So let's talk about this number, and let's talk a little bit about the natural exponential function, which is the function e to the x. So first, let's talk about the number e. So the number e is an irrational number that is equal to 2.71828182845 and I'm going to write ... because it goes on forever as an irrational number. It never repeats itself. Now, that might sound weird because there's this small part where it repeats itself, 18281828, which is a complete and total coincidence. But when I say it never repeats itself, I mean it never starts again with 71828, blah, blah, blah. It's not a repeating decimal with the same thing repeating over and over again. It is an irrational number, so the digits are going to go on forever and ever, and there's not going to be any pattern between how the digits are. So where does this weird number come from? You've seen irrational numbers before. The most famous one is pi, and we know that pi is the ratio of the circumference to the diameter of a circle. But e comes from a different place, and specifically, it comes from looking at the expression 1 plus 1 over n to the n power, and seeing what happens to this as n gets larger and larger and approaches infinity. So if we were to make a table of values for this function, n and 1 plus 1 over n to the n power, when n is 1, this expression is equal to 2. When n is 100, the expression is approximately equal to 2.70481. And I'm going to put some ... there because that's just an approximation. There's many more digits. When n is 1,000, the value of this expression is approximately 2.71692. And when n is 1 million, the expression is approximately equal to 2.71828. So if we look at what happens to this expression as n is growing bigger, from 1 to 100, this changes from 2 to 2.7, so it jumps a significant amount. I would say 0.7 is a significant amount. But then from 100 to 1,000, it only jumps from 2.70 to 2.71, 2.716, etc. And then if we go all the way out to n equals 1 million, it's only gone from 2.716 to 2.718. So we can see as n is getting larger and larger, very, very large, 1 million is a huge number, the function value, or the value of this expression, is increasing less and less and less. And in fact, we could say that it is asymptotically approaching a number, and that number is e, and I've given the first dozen or so digits right there. So if you were to graph the function f of x equals 1 plus 1 over x to the x power, you would see that there is an asymptote, a horizontal asymptote, that we're getting closer and closer to, and the value of that asymptote, the height of it, is this number e. And so we use this to define something called the natural exponential function. The natural exponential function is the exponential function f of x equals e to the x with base e. And the reason we use the letter e to represent this is because the mathematician that discovered this number was named Euler, which is actually spelled E-U-L-E-R. Many people, when they first read this, think that it's Euler, but it is actually pronounced Euler. And so this number was named after him. It's Euler's number. But it ends up having a lot of uses. We'll see one of these uses when we look at compound interest in the next lesson. And we will see other situations later where this pops up. It comes up in probability, it comes up in nature, and it ends up being a very, very useful number in many different fields. For right now, I just want us to do a few calculations so we can get used to it. And we're going to be using calculators for these because when we're doing math with an irrational number, it's very, very difficult to even get an approximation using pencil and paper because there are so many digits. So if we ever need to evaluate the exponential function for certain values, we will generally use a calculator. So if we have e to the third power, instead of writing out by hand 2.7182818 times 2.71828 times blah, 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 you just use a calculator. Most of them have an E button on them. You should be able to find that if you have a scientific calculator. If you've got one of those old school calculators that only adds, subtracts, multiplies, and divides, that's not going to be sufficient here. But if you have a scientific calculator, you should be able to type in e to the third power, and you end up with 20.0855 ... We need to do approximations because, again, this will be an irrational number, and the decimals will go on forever. So we just give an approximation, and we are good to go. So let's take a look at another one, e to the 4.8 power. I'm going to write the approximately equal to symbol, just so I don't have to write ... every time. And e to the 4.8 power is approximately 121.51. And we might see this within the context of a larger problem. So we might have something like 2e to the negative 0.53. In this situation, what I would do is I would figure out what e to the negative 0.53 is, because we know we have to do exponents before multiplying. And when you do that, you end up getting about 0.5886 on your calculator, and then you can multiply that by 2, and when you multiply that by 2, you get approximately 1.177. So we will use calculators in general when we're dealing with the natural exponential function, and it's important that you have access to a scientific calculator so that you can get practice doing these calculations so that you're confident enough that when a quiz or a test comes and you need to do a calculation involving e, you're able to do it without any fear or anxiety.